Okay, now that we've seen how we can find an inverse function, we're asked to find the inverse function and graph both f and its inverse. And when we do this, we're going to notice some very important properties of inverse functions. So let's find the inverse first of all. So I switch my f of x to y. Now what I do is I switch my x and y's. Wherever I see an x, I put a y, and wherever I see a y, I put an x. Now I try and get y by itself. So I'll add 3 to both sides. And now I will take the cube root on both sides. So I take the cube root of x plus 3, and I take the cube root of y cubed. Now notice I did not have to do plus or minus, and that's because you only use plus or minus when this is an even power and you're taking the square root or the fourth root or the sixth root. When you're taking an odd root, you do not have to do plus or minus. So now what we have is this. The left side is the cube root of x plus 3. The right side is just y. So therefore, y is equal to the cube root of x plus 3. And finally, we replace y with f inverse of x equal to the cube root of x plus 3. Okay, so now we have both f and its inverse function. So I'm going to write both of those down over here. So there's f, and here's its inverse. And now I'd like to graph both of these. So in order to graph these, here's what I'm going to do. I'm just going to graph f first. So f should be easy to graph. I'm going to say here's x and here's f of x. So I'm going to plug in some values, like let's say -1, 0, and 1. Let's just see what happens. -1 goes here. -1 cubed is -1. -1 minus 3 is -4. Plug in 0. 0 cubed is 0 minus 3. It's going to be -3. And if we plug in 1, 1 cubed is 1 minus 3 is -2. So if I were to graph this at -1, I'd be at -4. 1, 2, 3, 4. Okay. At 0, I would be at -3. And at 1, I would be at -2. And you could continue to graph more of this if you wanted to, and here's what you would see it would do. It would go like this, and then it would actually come up like this. Okay, now we want to graph the inverse. So to do the inverse, all we have to do is take these ordered pairs, -1, -4, 0, -3, and 1, -2. And remember, to get an inverse relation, we just flip them. So what we want to do is graph the point -4, -1, -3, 0, and -2, 1. So I go to -4, -1, that's -1, 2, 3, 4 -1s down here, -3 zeros here, and -2, 1 is here. Okay, now what we do is we could get more points, and here's what you would see it would do. It would go like this, and then here it would go like this. Okay? Now, the more points you get, the better, but if you did it, you would see that. Now, I want you to see something very interesting about inverse functions. If you imagine taking a dotted diagonal line, okay, and do a dotted diagonal line like this, what you'll notice is that if you kind of tilt your head, the function f and its inverse function is a mirror image over this diagonal identity function line. So that's kind of the property of inverse functions. If you have a graph of one, if you reflect it over the identity, you'll have the graph of the inverse. The way to do it is to just make a t-table, get some points, flip them, and plot them, and then you can actually graph it. To find the inverse algebraically, you have to go through that process of, turning this to y, switching x and y, solving for y, and then writing f inverse. So that's kind of all of it in a nutshell here.